Alrighty, let's get started. Okay, I'm going to postpone the due date of today's homework assignment. So if you have not done it yet, or you cannot finish it just yet, I'm going to postpone that to Thursday. So we have 2 more days to work on it. So that means today is a good day to ask questions about pre and post conditions, at least for conditional statements. Yes?
I like your avatar.
My avatar?
Dark helmet.
Big helmet.
Avatar? We should see it.
I think it's Big Helmet, right?
Yeah. Sweet.
From Spaceballs.
Yeah.
I'm surprised that you guys even know about Spaceballs.
That's good.
That's a classic!
Why would we not know?
I thought we were jam.
We're all geeks.
Yeah, but you guys are
I
much
was excited when I heard they
younger.
were going to do prequels to it, and then they never did.
Where's the search for more money at?
Exactly.
It was in a museum.
In the museum.
That's truly probably. It'd be just like episode 1.
But everyone's
Okay, let's go ahead and I'll just do one homework assignment like thing today, so that you guys know what I'm expecting, what is the format, and also, the reasoning that has to go along with your answer. Okay? So let's go ahead and get started with that. And I'm hoping today's recording, will upload without any problems. It's only that one single recording. On the same day, last Thursday, I have an evening class. I use exactly the same script and the same mechanism to record, and that one uploaded without any problems. Yesterday, I had another class, and that uploaded without any problems. So there's something about that particular video file, just that one, that has a problem, and YouTube just won't take it. VLC has no problem playing it.
Probably like some of the metadata. Some of the metadata is probably messed up or something like that.
Yeah, I think there's one time code that is messed up. So it thinks the video is like 7 or 8 hours long, but it actually is not. But I don't understand FLV, the format, enough to fix that 1 or 2 bytes. That's probably the only cause of the problem. All right. So we'll go ahead and take a look at this file. I'm not going to work on this file, obviously, but I will take a look at it so that we can kind of remind ourselves what is the homework assignment about. Okay, so here we have the homework assignment, and this time it is a text document. It's not a spreadsheet anymore because we are not going to trace the code. All we are going to do is to derive the pre and the post conditions. So in here we have a statement like this, in which the right hand side does not refer to the left hand side. Another one in which the right hand side does not refer to the left hand side. One in which the right hand side refers to the left hand side, and the other one that is also where the right hand side refers to the left hand side. So I'll go ahead and start with an example that illustrates the points, basically what I'm expecting from your submission, but not really doing your homework with you, for this homework assignment. So we'll go ahead and I will do it in just a plain text file. Now when I upload a plain text file, you can remind me to upload the plain text file. This will not open in Notepad correctly, but it will open in WordPad in Windows. Does everybody understand what is WordPad in Windows? Okay, very good. What?
Somebody said Notepad? What's WordPad, guys?
You can also open it in OpenOffice or LibreOffice. It's just a plain text file. Okay, so I'm going to give myself a different homework assignment this time. So I will start with x gets x times 2. Line 2 is y gets x minus 1. Line 3 is x gets y plus 1. And then line 4 is, I don't know, y gets y minus 5. Okay, there we go. Okay, so this is my, my demonstration. It definitely has some resemblance to your homework assignment, but it's definitely not the same either. In other words, this is only here to demonstrate the concepts and also the format of what I expect from your homework assignment. Very little of what I do here can be copied and pasted as your homework assignment. So you got to understand the concepts and then apply those concepts in order to do your homework assignment. And I'm also going to start with a precondition that is going to be different from yours. So in my precondition, I will start with something that is more abstract, which basically says, x is greater than, some variable k, and y is the same as another variable, let's say, j. Okay. So we start with, stuff like this. That's the precondition. Now we want to derive post 1. The question is, how do I get to post 1 given this is pre-1? Okay, there are several questions you have to ask yourselves in order to decide how to work on this. Okay, the big question, the first question, which is very easy to answer that you have to ask yourself first is, does the right-hand side refer to the left-hand side? So I will just write it down here. So in your answer to the homework assignment, you have to say the right-hand side of line 1 refers to the left-hand side. Obviously, copying and pasting is not going to work because in your homework assignment, line 1 does not have the right-hand side referring to the left-hand side. I intentionally changed the order of these things so that people cannot just copy and paste it. All right. Now that's good, because if the right-hand side refers to the left-hand side, there is a chance that we can use the substitution rule. Not always, but there's a chance. So the next question you have to ask yourself once you know the right-hand side refers to the left-hand side is whether the function on the right-hand side is reversible. In other words, you have to write something like this. The function f of x equals x times 2 of the right-hand side has an inverse function. In this case, there is an inverse function because if you multiply something by 2, how do you undo the action of multiplying something by 2? You divide it by 2. So then you have to state the inverse function. The inverse function f prime of x, the inverse function is f prime of x equals to what? X divided by 2. Okay? Is that okay so far? First, you check whether the right-hand side refers to the left-hand side. Because if the right-hand side does not refer to the left-hand side, there's no way it is reversible. Okay? But in this case, the right-hand side does refer to the left-hand side. So then you have to ask a second question. If I make the right-hand side a function, does that function have an inverse? Can I reverse that operation? In this case, the answer is yes. Now, if I multiplied x by 0, that would not have been reversible. There's no way for me to reverse the operation. But since I'm multiplying that with a non-zero in this case, it is a reversible operation. Yep.
How do we know it's non-zero?
Because 2 is non-zero. It's not x itself. It is it's the constant that you're multiplying with.
Okay.
In this case, it's a constant 2 and definitely reversible.
And how do we know that x isn't 0?
Well, if x was 0, then it will become 0. But it is still reversible because, in other words, okay, if you just focus on line 1, if I tell you right after line 1 that x has a value of 0, can you tell me what x was before line 1?
0. Yeah,
It has
0.
to be 0 as well. So that means it is a reversible operation.
Okay.
Okay, because there is a inverse function, we use the substitution rule. Okay? In other words, you have to explain all this stuff here. It is a lot of typing, but for the most part, you can kind of copy and paste and only change the parts that you have to change. The format has to be there, because you have to understand why we can use the substitution rule sometimes and why we have to use the forget rule other times. Okay, so then you have to write the template. The template is, the post condition of a line is based on the substitution operation applied to the precondition of that line. We take all occurrences of the variable on the left-hand side and replace each and every one with the inverse function of the right-hand side. That's the template. Okay? So this line is just a boilerplate. Okay? If you're working on a different line, the only thing you have to change will be which line we are referring to, what is the variable on the left-hand side, and also, if you choose to use function g, h, and so on, and for your other lines, you just have to change the name of the function, and also remember to change this variable inside the function. But the template is the same. This template is all it is saying is we can apply the substitution rule. We are deriving the post condition from the precondition, and we are replacing the variable x in this case with the inverse function applied to variable x. Is that okay? So we're going step by step, one little step at a time. So your solution has to have this step, and then the next step is nothing more than substitution. What is pre-1? Well, pre-1 is this, we already know. So I just copy and paste in here. And since you're going to be working with a text editor or word processor, you can also do copy and paste. There's not really a whole lot of typing in this case. And then the variable x, and then the inverse function, I figured that part out already here. So the inverse function is just x divided by 2. And I always use parentheses surrounding the inverse function so that the search and replace will work regardless of priority of operators. Are we doing okay so far with this? Okay. And then the third step, which is the last step, is actually going to apply the substitution operation. In other words, you just take this chunk here, and then you say, every time I see x, I will replace it with x divided by 2. And since there's only one occurrence of x in the entire condition, I only have one place where the substitution has to occur. And that's it. That's post 1. Are we doing okay so far with the format that I'm expecting, at least in the case of a substitution rule application? Okay. Then the next one is going to be line 2. But I cannot really start with post 2 until I know what is pre 2. So you have to say pre 2 equals post 1 because these two statements are sequential. Line 2 follows line 1 immediately. And that's why we can use this. That's why we can say the post condition of line 1 is the same as the precondition of line 2 because those two lines are right next to each other. And then after that, you have to ask some questions again. In this case, the right-hand side of line 2, does it refer to the right-hand side? No. Because if you look at x minus 1, does it mention variable y? No, it does not. Okay? So you can say the right-hand side of line 2 does not refer to the left-hand side. Now you don't have to use exactly those words. If you find a better way to describe what I just described, or you find a better way to say the same thing, go ahead and use the alternate form that you think is more appropriate. But the whole point is, if the right-hand side, which is this expression here, does not contain the variable on the left-hand side, then you have to apply a different rule. So if the right-hand side of line 2 does not refer to the left-hand side, we have to use the forget rule. Okay? Use the forget rule. When you use the forget rule, you have to do the same thing. You have to start with a template. Okay? So you have to start with a template. The template goes like this. The post condition of line 2 is the result of the forget operation applied to the precondition of line 2. But in this case, you also have to specify which part of this should I be forgetting. In other words, components containing which variable may no longer be applicable. Well, in this case, the variable that is being changed on line 2 is variable y. So that means any component that contains variable y may not hold true anymore after this statement. They may, sometimes it may, but in some other cases they may not. So we have to say components containing y, we have to forget. But after you forget those components, you can also say one more thing about y. You can say y equals to
x minus 1.
X minus 1, exactly. Now once again, do not use the assignment operator. That is incorrect. You have to use the equal symbol here because the assignment operator, the less than followed by a dash, that is specifying an operation. I want to make the left-hand side the same as the right-hand side. This is saying that y and x minus 1 are the same. And this is what you should write as a condition, as a post condition. Are we doing okay so far with this? Okay. Yep.
On the homework, you give us a precondition of a number.
Yep.
Whereas here you have a precondition of relationships between variables.
Right.
Would it work the same way with a constant?
It will work the same way with a constant, yes.
Okay.
Yep. In the case of a constant, sometimes you can do some more simplification, so you can come to a better conclusion. In this case, because it's just kind of fuzzy, sometimes you cannot come to an actual conclusion. I just made a mistake and nobody discovered the mistake here. Oh, never mind, I did not. Not yet anyway. Yep.
You didn't have to explicitly say that pre-2 equals the x over 2 is greater than
Well, that's coming here, because in this step here, the first step is really just this is a template. In other words, we are just saying okay, overall, what does it look like? The post condition depends on the precondition. We are trying to forget some components, or we may be forgetting some components of the precondition, but at the same time, we also know that y has to be equal to x minus 1 after line 2.
I meant before, a pre-2 equals +1, up there.
Up there?
Yeah, we didn't have to say that pre-2 equals, and then actually say what +1 is.
Oh, you mean right here?
Yes, below that or something.
That's up to you, because this is already connecting to post 1, and we already know what post 1 is. So there's no need to restate the actual expression if you don't want to repeat that. Good question. All right, but back to this one here, we do have to state what is pre-2. So now we have to go to pre-2, which is the same as post 1, and then we just copy and paste this portion into this place. And don't forget the comma y, because we have to remember that we are trying to forget components that mentions y. And then just the rest of the line is just from the previous line, like that. And then the third line, we apply the actual forget operation. Well, let's take a look at all the components. Does this component mention anything about y?
No.
Should we forget it?
No.
No, so we have to keep that one. So copy and paste. How about this component? Does it mention anything about y?
Yeah.
Yep. And since I do not know what was the value of j, there's no way to guarantee that x equals j is true at this point. Now it is possible that j and x minus 1 turns out to have exactly the same value. That is entirely possible. But it doesn't apply to all possible combinations of values of j and values of x. So as a result, I have to remove the condition that I'm highlighting right now, because it is no longer a guaranteed condition. Anything that is no longer guaranteed, I have to remove. So that's why this part I cannot just copy. So now I have the rest of the expression, which is a conjunction with this part here, and I just copy and paste it like that. And that's it. That's our post 2. Are there any questions about how I chose to use the forget rule and how to apply the forget rule in this case? Yep. The substitution rule? Okay, but maybe it is first important to understand why we can use a substitution rule. The substitution rule, okay, the mechanism of the substitution rule is actually fairly mechanical. Okay, you identify the inverse function, and then you replace all mentioning of the variable on the left-hand side with the inverse function applied to the same variable. So mechanically speaking, it is actually fairly straightforward. The question is, why are we applying the substitution rule? Okay, I think that's a more important question to answer before we even answer the questions about this. This is all mechanical once we understand the concepts. If we go back and take a look at the precondition of line 1, it looks like this. In other words, we know that before line 1 executes, someone is going to guarantee that x has to be greater than k, and blah, blah, blah. The blah, blah, blah really doesn't really matter because we are not changing the value of y or j, so that part stays the same after the operation. So the question is, after line 1 executes, what can I still guarantee? Okay, that's the question. Well, then the question is, what is line 1 actually doing to x?
Changing value of x.
It's changing the value of x because it's an assignment statement, but to be more specific, it is doubling the value of x. Is that okay? Does everybody understand that line 1, all line 1 is doing is doubling the value of the variable x? If it was 5, now it is 10. If it was 3, it is now 6. Is that making any sense? Now, let's take a look at pre-1 again. Pre-1 is saying that x is greater than the value of k. The value of x is greater than the value of k before it gets doubled. Okay, that's all it's saying. So knowing this, and I know that line 1 is going to double the value of x, what can I say about the value of x after I double it?
Still bigger than k.
Well, we know that x divided by 2, the value of x after line 1, if I take that value of x and divide it by 2, what do I get?
It's greater than k.
I get the value of x before line 1 executes. And what do we know about the value of x before line 1?
It's greater than k.
It's greater than k. So that's why, that's why I want to get to this point. I want to be able to state something like this. If I take the value of x after line 1 executes and divide that by 2, I get back the original value of x before line 1 executes. And we already know that that value was greater than k, so that means if I take the new value of x and divide it by 2, that value after the division by 2 has to be greater than k as well. Is that making any sense? The rest is really just mechanical steps so that we can get to the conclusion like this. Yep.
When we do the inverse functions, when we say what the inverse function is, we don't have to prove that algebraically.
You do not have to prove it,
I'm
but
asking if you want us to go through line by line and say f of x of x, or f prime of x of x.
f prime
back.
of f of x is x.
Do you want us to prove that?
No, there's no need.
Okay. Thank you.
On the other hand, if it is wrong, then I have to deduct points. So I don't think in the homework assignment there's anything that's tricky. So I don't think people will have any problem with reversing it. Okay. But am I addressing your question? Okay. And then the rest of it is really just doing about the same thing. Then we can move on to line 3. Without actually doing it, I just want to kind of verbally mention it. It should still be recorded anyway. On line 3, which rule should be applied? The forget rule, because
The right-hand
Replacing the
side
value
is
of x
equal
with y is 1.
the bottom line is the right-hand side, or the function on the right-hand side is not reversible. It is not reversible simply because it doesn't even mention the variable on the left-hand side. There's no way it is reversible. So you have to apply the forget rule. What about line 4?
substitution.
Line 4 is reversible, okay? Because y gets y minus 1 is reversible. So that means we have to apply the substitution rule, okay? But I'm hoping that after this explanation, people understand why we're using the inverse function for the substitution operation. It's because we want to reverse the value of the variable after that line to become the same as the value before that line, so that we can keep the relationship of that expression with all the other variables and constants. Yep.
I still don't understand why for line 4 it's substitution rather than forget.
Well, let's go ahead and take a look at line 4. Now, I'm not going to do it because it's really a replication of stuff that we have done already. The first question is does the right-hand side of line 4 refer to the right-hand side of line 4?
Yeah.
Yeah.
Y minus 5
Right.
mentions y. And that's why the right-hand side does refer to the left-hand side. Okay? So that means we have to ask the second question. The second question is, if you look at the function, f of y is y minus 5, can I reverse that operation? If I take 5 away from something, is there a way to reverse it? The answer is yes, there's a way to reverse it, because you can add 5 back, and then the value would not have, gets back to the original. So that's why you can find an inverse function. So that means this also applies on line 4. The function f of y, in this case, equals y plus 5 of the right-hand side has an inverse function. Oops, I take it back. Okay, the function f of y equals y minus 5 has an inverse function, and the inverse function f prime of y is y plus 5. Okay, so once we know that it is 1 reversible, then the right hand side refers to the left hand side, and 2 it is reversible, then we know we can use the substitution rule. And at that point, it's just a matter of formality. You just use the template, and then replace components in the template with the actual precondition of that line, and replace the inverse function with the actual inverse function for that particular line, and then apply the actual substitution operation, and you're done. Is that okay?
Yeah.
All right.
Would it be just as correct to put x is greater than 2k?
That is just as good.
Okay.
Yep. So if anyone wants to do algebra, some algebraic, manipulation, that's fine too. As long as it is somewhat clear to me that they're equivalent, it will be fine. And I think my algebra is still okay. I haven't taken a test, lately, as in the past 20 years, so I'm not really quite sure where my algebra stands. But my 6th grader said that I can still do her homework, so yeah.
That's all that matters. Is there ever an instance where you would do both substitution and forget into one line?
That would not be possible, because you only have to pick one of the 2 rules. Any other questions? Yep.
In the forget rule, if you actually knew that x was a constant, where would you put that in on the far right in the bottom? Like y equals x minus 1. Would you put like y equals, say, x at a value of 15? Would you put that in right there in the first line?
That's a very good question. The question is, if we already know the value, the exact value of one of the variables, should we, resolve all the references to the variable to the constant itself? And the answer is yes. That will buy you something in the end. Okay, because it's decoupling the variables from each other, and that is a useful operation.
Does it matter where you do that along the way, or as long as it just ends up?
You should do it as soon as possible. So every time you see a constant, every time you see k equals something, and then you have something else that either equals k or refers to k, you should resolve and just get rid of the mentioning of k and use the constant of whatever k equals to. Yep.
So for formatting's sake, after we do the template, which is the first part of those 2 equals template, after that then we should plug in the value of the constant?
Yeah, you can have one more step if you want to. Like after this step here, you can just have one more step and plug in the constant as the last step. Okay. Any other questions? Very good questions? Yep.
So first one, like x over 2 is like bigger than k.
Which line are we talking about?
The post one. The
Post one?
Yeah, the
This one?
last one. Yeah.
The last portion? Yep. What about it?
So if after line 1, like we know x will equal 15, and we doubled x, so x will equal 30. So just write 30 over 2 will equal like 15.
It's greater than k.
No, if it was like equal k, I mean like equal x.
Okay, let me use an actual example. Okay. Let me show you one example where the substitution of the constants is going to buy you something, because if you don't do it, you cannot get to the same conclusion at the end. Okay. So we'll start with x gets x plus 2, and then we'll basically have a statement like this, and then on line 3 we'll go ahead and change. We'll change x again, so we'll say x gets 10. Okay, that's it. So let's take a look at this particular example, and we'll start with the precondition, knowing something about x already. So in this case, we'll say the precondition of line 1 is that we know that x is x has a value of 3 to begin with. Okay. How do I get to post 1? Using the same stuff that we talked about. The right-hand side of line 1 refers to the left-hand side, because the right-hand side is the expression x plus 1, which has a mentioning. It refers to the variable on the left-hand side. The next question is, does it have an inverse function?
No.
Okay. The right-hand side function, f of x equals x plus 2, does it have an inverse? Is there a way to reverse adding 2 to something? You can reverse it by subtracting 2. Okay, so has an inverse of f prime of x equals x minus 2. Is that making any sense so far? I'm not using exactly the same wording as before, but essentially capturing the same information. So which rule should we apply? Apply the substitution rule. Okay, that's easy enough. So we say post 1 is based on the substitution of pre 1. We take all occurrences of x, which is the variable on the left-hand side, and replace each one with x plus 2. And then in the next line, we just go ahead and substitute what exactly is pre 1. Pre 1 is exactly x equals 3. Yep, go ahead.
Should be x plus 2 or x minus 2?
Yeah, I got this wrong. This has to be x prime of x, f prime of x, because I'm only referring to the inverse function first. And then in the next line, I actually refer to the inverse function, which is x minus 2. Very good. Good catch. And then we just apply the substitution here. So we end up with x minus 2 equals 3. And for those of you who really do not like it like this, because you can actually simplify it a little bit, you can say x equals 5. Is that okay? Now the next line is the one that is kind of interesting, because it looks like this is something that we have done already. So post, okay, then we have to say pre2 equals post 1, because the two lines are sequential. Okay. Then we try to talk about post 2. Does the right-hand side of line 2, the assignment on line 2, refer to the left-hand side?
No.
Okay, so we'll go ahead and write that. The right-hand side of line 2 does not refer to the left-hand side, and as a result of that, use the forget rule. There's really nothing else you can apply in this case. So when you apply the forget rule, you say post 2 equals the forget operation applied to the pre-2, the precondition of line 2. And are we forgetting components that mention x, or are we forgetting components that mention y? Y. Very good, because it's the variable that is being changed in this case. And what else do we know? We know that those two variables must be the same right after line 2, don't we? So now we say y equals x. Now since equality is symmetric, you can say x equals y2. It doesn't matter which way it goes. Okay, so in the next line, we have to figure out, okay, what exactly is pre-2? Pre-2 is the same as post 1, and we know what post 1 is. X equals 5 is post 1. So we just copy and paste it. And the rest, we just kind of copy and paste as well. All right, can someone tell me what is the result of the forget operation? Does it actually do anything? No, it doesn't do anything, because the expression was just simply x equals 5, which has no mentioning of y whatsoever. So I have no reason to forget the only condition in the precondition. So as a result, the forget operation really doesn't do anything. We have x equals 5 back exactly the same way as before, and then we say y equals x. Now this is where, exactly what you were mentioning, because now that we know x is exactly 5, and we know y is exactly x, we can simplify this. the way we simplify it is we say x equals 5 and y equals 5 as well. Does it make sense? Because we know, x is a particular constant, we can just say that y is also just that constant, because y equals x. Now, this is an important step, because without this step, I cannot come to the conclusion, of the next one. The next line, which is line 3, and this is also an easy one. This is a really, really easy one. Does the right hand side refer to the left hand side? One side is a constant, it's just a number. There's no way it can be referring to the variable on the left hand side. So this is an easy one. We say, oopsie, uh-oh, it's undoing a little more than that.
Control Z again. One more time.
There we go. I know how to do inverse functions, but I don't know how to use Control Z. The inverse function of an editor. Okay, so we have the right-hand side of line 3 does not refer to the left-hand side. Grammar there. Okay. So once again, we use the forget rule. So the forget rule is fairly simple in this case. Post 3 is forget pre-3, and components of which variable are we trying to forget in this case? X, because x is the variable appearing on the left-hand side. And after that, what else do we know? Let's go back to the line 3. X equals 10, right? Okay. So we say x equals 10 here. And what exactly is pre-3? Oh, I forgot one thing. I forgot to link the two lines together. I forgot to mention that pre-3 equals post 2 because the two lines are sequential. Okay. Now we can proceed. We can just take what is pre-3. Pre-3 is post 2. Post 2 is this conjunction. Are we doing okay so far? All these steps are very, very mechanical. Okay, now, what do we have to forget in this case? The original precondition is x equals 5 and y equals 5. And we are trying to forget components or anything that mentions x. So that means x equals 5 has to be forgotten. Okay, we cannot keep that 5. But y equals 5 can be kept, right? So that means, after the forget operation, we get y equals 5 remaining, and x equals 10 is the factor that we're adding in this case. So at the end of 3 lines, okay, these 3 lines, we can now conclude y equals 5 and x equals 10. However, think about what if we don't perform this step here? What if post 2, we just stop at this point? If post 2 is only stating x equals 5 and y equals x, then the forget operation would have forgotten both conditions. Because we would have x equals 5 and y equals x. And since we are forgetting everything that mentions x, that means the entire pre-3 we have to forget. That means we lose track of the fact that y equals 5. By performing that one extra step here, let me highlight that line. By performing this one extra step, we basically decoupled, we basically isolate y from x after this point. In other words, we no longer need to define the value of y using the value of x because they are the same at this point. They are the same constant. But that is a very important step because without that extra step, we would not have been able to conclude that y equals 5 after line 3. Yep.
Do we have to complete that second step with those two?
Yes. Yeah, the notes actually says that too. I basically rewrote my notes a little bit to include this one extra part. All right. So are we feeling a little more comfortable with the homework assignment? Okay, once again, the due date is postponed to Thursday, If you have turned in something already, and after today you're thinking, well, maybe I need to change some parts of it, it's okay. You can download your document back from Moodle, work on it, and then resubmit it. Okay, I programmed Moodle so that you can resubmit as many times as you want before the due date. And the due date has just been moved to 10:30 on Thursday. All right, is that good so far? Okay. So let me make sure that I save at least this file. So even if the video fails to upload, I can at least save the document itself. So that's your homework assignment. And we now continue to talk about pre and post conditions. But this time we'll move on and talk about loops. And loops are very nasty when it comes to pre and post conditions. That one. All right, so here we have a loop. And the question is, can we do anything about pre and post conditions with loops? Okay. And this one is kind of nasty because let's draw a picture on the whiteboard. So this part cannot be captured because it takes me a lot longer to draw a picture in the computer, than compared to the whiteboard. So I'm going to draw the picture on the whiteboard. If I look at the pseudocode of algorithm 3 and want to draw a picture about it, it's really not too hard. Okay. The first thing is, we have a little bubble here that says, x gets initialized to 0. Okay, because that step is before we get into the loop. It is not a component of the loop. The next one, it will be from line 2 to line 4 is a pre-checking loop. A pre-checking loop has a kind of strange shape because it has a loop back from after the operation. So we have an operation inside the loop. After we perform the operation, it has to go back into the loop. The action that is inside the loop in this case is to increment x by 1. So x gets x plus 1 goes here. But before we get into the action, we have a chance to get out. This is how we can get out of the loop. Like so. I will use arrows to indicate that these are basically one-way streets. But every time there are two ways to proceed from a single point, you have to expect there's a question somewhere that you can answer. That way you can choose either the path that is labeled true or the path that is labeled false. Is that okay so far? We have seen this picture already. And in this case, the question, or if you look at this as a trail map, there's a little post, next to the junction, next to the fork. And the question is it true or is it false that x is less than 3? If it is true, follow this path straight down. If it is false, you follow the path on the right-hand side, and that will get you out of the loop. Are we doing okay so far with the picture representing the logic of algorithm 3? Is that okay?
Picture's fine. The picture's fine.
The picture's fine. Very good. Okay, let's just say that pre1 is here. The pre1 is basically saying what do we know for sure at this point of the picture. This is our pre1. And let's just say that pre1 is true. Now tell me again, what does it mean when the precondition of a line is simply true?
We can make it to that point.
We can make it to that point. What else do we know? Nothing. Nothing. We know nothing about any of the variables at that point, which is fine, because I'm just going to do something to x anyway. So there's no need to know anything about x because whatever we know about x is not going to be true anymore after line 1. So that's pretty easy. I'm not going to go through the derivations, but can we just kind of skip to the answer here? What is post 1, or in this case pre2? Okay, it's easy. Pre1 or pre2, which is post 1, is simply saying x equals to 0. There was nothing to forget because true itself does not mention anything about x, so there's nothing to forget. True and x equals 1 is just x equals 1 because of the simplification. Okay, so those parts are not really too nasty. We kind of we get it. The nasty part is this part here. If I use pre and post conditions, this is pre what? It's pre 3. Okay, this is pre 3. Okay, so I label this as pre 3. So what should I say about pre 3? Well, first of all, how many ways can I get to this point of the picture?
Two ways.
There are 2 ways to get there. Okay. Now, how come there are 2 ways to get there? Well, one way to get there is when we get in here the first time. So we are coming in from pre 2. In other words, if you want to say what is pre 3, one way to get to pre 3 is go through pre 2. Now, if we go through pre 2, to get here, okay, let's just say it is pre 3. What is the other way to get back to pre 3?
Post 3.
Post 3, because if you look at this operation, if we had performed this operation at least once, that means in order to get back to here, we have to follow this path all the way around and then come back down again. So that means pre 3 actually can depend on post 3. So pre 3 is pre 3 or post 3. Okay? And then you have to take this entire thing and then say, regardless of whether I come in here the first time.
That was funny.
Evil laugh.
Get him, Tag. Get him.
Not laughing anymore, are they?
It's a funny moment. I'm so sorry.
Thank you. You too. Oh, you too.
Happy Single Awareness Day.
That was funny.
It was a funny moment. Yeah, I would say.
Yeah, really funny.
What, you think somebody's in this class is single?
Okay, but it does give you guys a chance to take a break from this stuff. So. All right, but there is one thing that is always guaranteed when I am about to execute line 3. What has to be true, regardless of whether I'm coming back from another iteration or whether I come in the first time? The condition has to be true, okay? If I'm here, this condition has got to be true. So I have to use the conjunction and then say x is less than 3 must be true. There's no way around this one, because in order to end up here, this condition has to be true. Are we doing okay so far with the analysis of the precondition of line 3? Okay. Now line 3 looks kind of nasty because it depends on post 3. What do you think that will make post 3?
1.
Post 3 is even more nasty, isn't it?
Yeah.
Now, why is post 3 even more nasty? I'm just going to write it on this side.
Because it depends on itself again.
Okay. Now, let's think about all the stuff that we talked about today. You're exactly right, but I want to show how it depends on itself. If you look at line 3 and apply the stuff that we talked about just earlier today, does the right-hand side of line 3 refer to the left-hand side? X plus 1 obviously refers to x. Can I undo the operation of adding 1?
Yes.
Yeah, you just need to subtract 1. That's an easy one. So should I apply the forget rule or should I apply the substitution rule? The substitution rule. All right. So we'll go ahead and just write out the template of a substitution rule. So post 3 is the substitution rule applied to the precondition of line 3. And we are taking all occurrences of x, which is the variable on the left-hand side of the assignment, and replace it with the inverse function, f prime, applied to x. And then we'll go ahead and expand everything. The precondition, according to that, is, it's kind of a big mess, because it is pre-2 or post-3, and then the whole thing, and x is less than 3, because x is less than 3 is a conjunction that we apply as the last operation, comma, with substitution occurrences of x by f prime of x. In this case, what is f prime of x? What is the inverse function of x plus 1?
X minus 1.
X minus 1. Okay, that's easy enough. All right. Now don't we have a problem? What is the problem here? Why can't we do this step any further? We are kind of stuck here.
Because we don't know the pole 3. What's pole 3?
Because I can't really do the substitution unless I know what post 3 is. But I cannot know what post 3 is because this whole right-hand side is trying to figure out what post 3 is. Okay? Doesn't that kind of give you a sense of what a loop can do? And that's why sometimes we call certain people loopy, right? And that's because they think about this sort of thing too much. All right. So we'll kind of let it sit a little bit here. Okay. Instead, we'll try to think about something that's more pleasant, like what is going to be the condition here.
So we're not
Okay, this is what I would call post for, which is the statement or the condition right after the the pre-checking loop here. How can I say what is post for? Yes. Wake up, come on. All right. How can we say something about post for here? Well, first of all, how many ways can we get to post for? There are really two ways to get to post for. One way is to go all the way from here, skipping the operation altogether, and then exit right away. The second way is to go through at least one iteration and then get out like that. So there are actually two ways to get out.
Well, no, because if x gets the value of 0, then there's only one way. It has to go through the loop 3 times.
But that's only because of the constants that we are using in this particular example.
Okay.
If I don't tell you what this is, how I initialize x, and I don't tell you this is actually 3, then you have to make provision for both cases.
Okay.
Okay. So we'll just make the most general case. They all simplify to an easy one in this case. So when we express what is post for, then we have to say, well, there are two ways to get to post for. One way is to go through pre-2 and only pre-2. The other way is to go through post 3, right? Because if you go through one operation at least, then you will come back to this point in which post 3 will still be true, and then you get out like that. But at the same time, we also know one thing for sure as well. What is that? X is less than 3 has to be false, okay? Because in a pre-checking loop, it is saying as long as x is less than 3, we have to stay in the loop. So the only way to get out of the loop is when x is less than 3 is false. I'll go ahead and simplify that and just say that x is greater than or equal to 3. Is that okay? I'm just combining the step of negating it, and turning it into a greater than or equal to. All right. So if we just look at all the things on the board right now, which item appears many times? It appears in the loop, and it also appears out of the loop. Post 3. Okay, post 3 seems to be the problem child here. Okay, because everything else we kind of know how to derive it, but post 3 is the one that we cannot really do anything about, because in order to derive its definition, it relies on itself. But that's a part of the nature of a loop. That's why loops are loops. It's because you can go back to the same statement. You can go back to the same point. All right, and that's why post 3 has a special name. Okay, I'm pretty sure you guys know. Just remember from your childhood, from your kindergarten days. Don't you think all the problem childs or problem children have names?
Yeah.
The teacher never remember names of good students, do they? It's only the bad students, they will say, oh yeah, Johnny, I remember Johnny. Yeah. So post 3 here is Johnny. It has a special name. Its name is called a loop invariant.
Loop invariant?
Loop invariant. So post 3 is our loop invariant, which means it is one condition that does not change. It's always there. Because guess what? It is here. Well, that's where post 3 is defined. It is a component of pre-3. It is a component of itself. And it is also a component of the post condition of the entire loop. So this is the one condition that is kept the whole time. And that's why it is called a loop invariant, because it does not change. It is always there. Yep.
But doesn't it change if the condition is not met? The post 3 becomes a post 4.
But it's still here. You cannot get rid of it. When you get out of the loop at post 4, post 3 is one of the components.
But it becomes a post 4 when the condition is false. What if you loop several times? Doesn't that post change as well?
No, it does not change because it is still here. We just derived post 4 and say that yes, post 3 is one of the components of post 4. In other words, when you get out of the loop, the post condition of line 3 has to be true, still has to be true. There may be some extra strings attached to it, but whatever post 3 is, still has to be true when you get out of the loop.
So if you're to loop many times, that still be considered post 3?
Well, because of the picture, right? I mean, post 3 is here, and if you look at this condition here, it has to be true. Okay, let me see if I have a different color. We don't have any other color, but I'll use a dotted line. Okay. Do we all agree that post 3 has to be true at this point? That's the definition of post 3, right? So, okay, so this has, the dotted line specifies where post 3 has to be true. Okay, one way is to come back to itself, and the other way is to walk out. So by the time we get to post 4, post 3 can still be true. Now, in this case, it's a disjunction, which means maybe it is and maybe it's not. But in this case, it is.
I was thinking after when it goes to the loop, the pre-3 becomes a pre-4, then goes to post 4, then loops again, it becomes a pre-5, then post 5.
No, it's the same line. Because the 3 refers to line 3.
Yes.
Okay? All right. So now we have a fine mess on our hands. And then, of course, to deal with any fine mess like this, we apply magic. So we don't apply forget, we don't apply substitution, we apply magic. The magic means, it depends on experience. Okay? So based on experience and years and years of training in math and so on and so forth, I come to the conclusion and say, well, TAC is suspecting the post 3 is as follows. TAC proposes post 3 is x is less than or equal to 3. Not just less than, but less than or equal to. Okay? And that's just coming from years of experience and other classes that I have taken. In this class, we just have to say, well, does it work out? Will that work out?
Yeah.
Yes.
Well, let's put it in and see if it works out, okay? Because, to derive post 3 may be difficult, but to prove that it works is not difficult. It's just basically mechanical. So once we suspect that post 3 is just x is less than or equal to 3, the first thing we'll do is we'll plug it in to pre-3. Okay? We already know what pre-3 is. Pre-3 is this mess here, right? So we'll go ahead, and this time I'll use the whiteboard. So this is a combination between the whiteboard and the pictures that I drew here. If anyone wants to take a picture of this and send a picture to me, and then I can post it on Moodle, that's fine too. All right, so let's switch back to my text editor here. Okay. It's also in the notes. So everything is actually just a repetition of what is already written in the notes itself. But I want to do the derivation live, just so that you guys can see how it is derived step by step, and it gives you a chance to ask questions as I go through these steps. Okay, so this is referring to what? Okay, I'll do better. How about that? The full URL. Okay, so now you guys know what I'm referring to. Okay, so referring to that thing, now we know, okay, tag suspects post 3 is x is less than or equal to 3. That's what I'm saying. So one thing we know is, since we know how pre2 relates to, pre3, sorry, pre3 is pre2 or post 3, and then the whole thing with a conjunction, and x is less than 3. We established that here when we looked at the picture. Is that okay? Yeah, this is just a result of looking at the picture itself and say, by the time we get to pre3, what has to be true? And we figure that this has to be true. Well, we already know what is pre2. What is pre2?
X equals 0.
Okay, pre2 is x equals 0 because we have the initialization of x to 0. What is post 3? Well, tag has a suspicion that post 3 is x is less than or equal to 3, right? Okay, the rest I just copy and paste. All right, now we look at this mess here and go like, whoa, that's a little too complicated. Can we simplify this a little bit? Well, we do one thing at a time. Can we simplify x equals to 0 or x is less than or equal to 3? Is one of these things restating the same thing as the other one?
Yes.
Okay, which one is the more restrictive description of x?
X equals 0.
X equals 0 is a very narrow definition because it says x has to be 0. X is less than or equal to 3 says, well, it can be 2, can be 3, can be 1, can be -1, can be -200. We don't know what it is, but it has to be less than or equal to 3. Since this is a disjunction, do you think we can get rid of one of them?
Depends. Depends on where you came from.
No, it does not depend on that.
X is less than 3 is implied by x equals 0.
We can keep that portion. Okay. How many of you have taken a class in set theory? The unions and the intersections of pictures, graphs? No? Okay. No one? Okay. How about the number line? You guys know about the number line?
Yeah.
Okay. Let's look at this from the number line perspective. Okay. And I still just have enough space to do it here. This is our number line. We have 3, 2, 1, 0, -1. The rest of the values don't really matter. Okay. So if you look at this number line and we look at x equals to 0, how many spots of the number line am I specifying? One single dot, right? X equals to 0 means this dot here. And then you look at x is less than or equal to 3. How many spots of this line am I specifying? Well, technically it's infinite because it specifies everything from here and everything to its left-hand side. Okay. What do you think a disjunction will do when I'm trying to merge these two into one?
The weak one.
The more general one wins because it's a disjunction. It's saying or. Is that making any sense?
Yeah.
Okay. So which one should I keep? Which one is more inclusive?
X
Is less than or equal to 3 is more inclusive. It includes the case of x equal to 0. So I don't have to re-specify the case of 0. If you want to look at this the other way to understand why we can just get rid of x equal to 0, just kind of imagine this expression here. Instead of saying x equal to 0 or x is less than or equal to 3, I can say x equals to 3, or x equals to 2, or x equals to 1, or x equals to 0, or x equals to -1, or x equals to -2, and so on. Am I adding any more to just x is less than or equal to 3? No. So that means those extra statements do not add any value. They serve no purpose in the disjunction. And as a result, I can simplify the disjunction to just x is less than or equal to 3. Okay, now we have the conjunction next to it. Is there any way to simplify this?
It's different to 3.
Well, first of all, is one condition covering the other condition entirely?
Yes.
Okay, one is completely included in the other one. When we have a conjunction, are we trying to be more restrictive, or are we trying to be more inclusive?
Inclusive.
More restrictive. A conjunction is more restrictive because both conditions have to be true for the conjunction itself to be true. In other words, there are more chances now for the entire thing to be false, if you want to look at it that way. Okay? So if conjunction is trying to make things more restrictive, and these two conditions, they are related in the way that one is a smaller portion of the other one, which one should we keep? The more restrictive one or the more general one? The more restrictive one. Which one is more restrictive?
X is less than 3.
X is less than 3 is more restrictive because it excludes the case of x equals to 0. Okay? So this entire thing simplifies to x is just less than 3. Well, that's kind of cool because the precondition of line 3 is now just simplified to x is less than 3. Well, now that we know what is pre-3, we can derive what is post-3, right? So we now, now don't do this in your homework assignment. I'm skipping a few steps here. Post-3 is the substitution of pre-3. We are taking occurrences of the variable on the left-hand side and replace it with f prime of x, which is the inverse function. Okay, so we are substituting pre-3. Now this time pre-3 is simple. It's just x is less than 3. X is x. F prime of x is x minus 1. Because that's the inverse function of x plus 1. And, well, this is really easy. We just have x minus 1 is less than 3, just like that. Now, if we want to simplify this, there's a way to simplify it that you are probably not aware of. If I tell you that x has to be an integer, how can I restate this statement here? X minus 1 is less than 3. Well, let's do the one that is obvious first. We can always add 1 to both sides of the inequality, so we end up with x is less than 4. But that means you're wrong, because x is less than 4 is not the same as x is less than or equal to 3. But what if I tell you that x has to be an integer? If x has to be an integer, don't you think saying that x is less than 4 is the same as saying x is less than or equal to 3?
Yeah.
Yeah? Okay, so we can say that in this case, x is less than or equal to 3, and I will put in parentheses here because x is an integer. How do we know x is an integer?
Okay, that's the way.
Because it started off with 0, and the only thing I can do to x is to add 1 to it. So it has to be an integer because it started off as an integer, and we are making changes that are also of integer values to x, so x has to end up as an integer during this entire loop. All right. Well, what have I just done? I have just proven myself right? Go ahead. There's a question?
I was just going to say, do you want us to put in the brackets then every time we do it, or is it just a line?
You won't have any homework assignment or exam questions concerning loops. So this is really just for exposure purposes, so you don't have to do anything like this. Yep. Now you tell me I could have dozed off and taken a nap for the past hour and a half. But to that I have this answer. You should have watched my video from last semester and know that already.
Yes, that's true.
In fact, you can take this entire class by watching my videos from the past year. So there may be like 3 or 4 sections of classes we've recorded already at this point. You can even review the questions in exams too from past years. That's perfectly fine with me because I never reuse questions. Not intentionally. Sometimes I forget that I have asked a question already, and I might end up asking the same question again.
Do you ever go over your exams with your students afterwards?
Afterwards?
Yeah, and then record it and put it back on YouTube?
Yeah, I always do. Yeah, it's not a secret.
Okay.
Okay, now, we're not done yet. We still have a few minutes here. we're not done because post 3, as interesting as it is not the end result that I want. What is the end result that I really want in this case?
Post 4.
It's post 4. I want to know what happens when the loop exits so that I can continue with additional statements after line 4. So let's go ahead and work with post 4 in this case. Post 4, according to this picture, is pre-2 or post 3, and then the entire disjunction and x is greater than or equal to 3. Okay? We know that because we analyzed the picture itself. Okay? This here is based on an analysis of the picture itself. It's not, any, it's not really derived. It is just from the picture. Well, now that we know what is pre-2 is x equals to 0. We know what is post 3. It is x is less than or equal to 3. And then we have x is greater than or equal to 3. First thing is we'll go ahead and try to simplify this. But we already know how to do it, right? We just did it. So we can simplify the disjunction to x is less than or equal to 3. And then we say and x is greater than or equal to 3. That looks kind of funky to me. Is it possible?
Sort of. Well, the second.
It's possible
Can't be
because
greater than 3.
Because x equals to 3 is the only case to make this entire conjunction true. So now we can simplify this to x is 3 itself. So as post 4, we now know that when we exit from the loop, x has to have a value of exactly 3. It's not just that it is greater than or equal to 3, but it has to be 3. Okay, so that's kind of how we deal with loops. Okay, when you deal with loops, the biggest obstacle is going to be the loop invariant. You have to identify what is the loop invariant, and then looking at the loop, most of the time it has to do with the exit condition itself. That's where you get a clue of what the loop invariant may be in this case in the loop. Okay. Are there any questions about this derivation? This whole big mess? No? And all we have done so far is to prove a result that we could have gotten by tracing. Okay?
Or we could have gotten just by looking at it. We don't even have to trace this one.
But on the other hand, when you have more complicated algorithms, like a sorting algorithm or a search algorithm or something along that line, it's not as simple to trace it anymore. And when you trace, you can only prove it in one specific test case. You never know whether it will work the same way or whether it will be correct in the next test case. This is absolute because we just proved the properties using rigorous mathematics. Okay. Now we still don't have enough topics for the exam yet because I have to. Well, okay. This is what we'll do. On Thursday, I'll give you a practice exam for the first exam in this class because we have covered enough material, just not the twists that I will put into the exam questions. So what you should do. Okay. Let me make sure that we save this file. We go back to Moodle first. So what we'll do is we'll go and take a look at the practice exam 1 on Thursday. Okay, that's not really a practice exam. It's not watered down. This is exactly what I asked in the previous semester. Okay, in fall 2011, that's the actual exam 1. But it will serve as our practice exam 1 so that we can see the same type of questions about the same type of difficulty, and I will talk about the answers of practice exam 1 on Thursday. So that means next Thursday will be the actual test. Okay? The actual test, don't leave just yet because this is also important stuff. The actual test is going to be open book, open notes. Okay, you can bring in anything that is either handwritten or printed ahead of time. Because I know someone is going to say, but how about I write something during the test and pass it to my neighbor? No, that is not written ahead of time. Okay, so because I know people are smart. Yep.
My notes are written ahead of time. Say, timestamp. So can I use my notes?
Yeah, you can bring your own notes. You can print out my notes if you want to.
Computer, though, right?
You have to print it out. It has. You cannot use a computer because I don't want to have some people who have access to computer to have an advantage over people who do not have a computer. Calculators are allowed. I don't think anyone will need a calculator because we're just dealing with multiply by 2, division by 2, add 1, subtract 1, that sort of thing.
You said you're going to put in some twists.
Sorry?
You said you're going to put in some twists, so.
Oh, the twist is nothing that your calculator can handle anyway, so your calculator will not be very helpful in that case. Okay, but go ahead and read the practice test ahead of time. Try to work out as much as you can, and then on Thursday we'll talk about the answer of the practice test, and hopefully that will help prepare you for the actual exam. Okay, I'll see you guys on Thursday. And I need to give you back your form so that you can take it back to DSPNS. Just hold on a second after this. I think they gave you the wrong form.
I know.
Yeah.
So I need to redo it.
Yeah. The form that you need is called a time conflict petition form. Yeah, time conflict petition form. I know it has nothing to do with time conflict, but that's the form that they want you to turn in. So I'll just sign and date it anyway. But they may ask you to come back and do this again. Now you have to take this to the dean's office in room 133. You have to take it to the dean's office so that the dean can sign his portion, and then you have to take the signed forms all the way back to the records and permission.
Yeah. Okay.
Yep.
If we already turned it in, can we just resubmit any time?
Yeah.
Oh.
Absolutely.
Yeah.
Yep.
Same thing.
Same thing. Did you guys get the right form? Okay, you might have got to the wrong form, but you need to fill in your parts first. So I cannot sign blank checks. Okay, you got the right form. Yes, you got the right form because this is a, let's see, student petition. Nope, you got the wrong form. So the form should have like conflict petition or time conflict petition or something like that on it.
Yeah, but like when.
Well, I asked them in the office. That's the form they gave me.
Yeah, exactly.
Well, in that case, fill in your portion first, and then I'll fill in mine and sign. Let me give you back your.
Do you have the
And I don't have
No.
it.
Same thing as well. Got the
It's in my
wrong-
office, so you have to. Do you have a little bit of time after this? Do you have another class?
I don't have class until.
I can give it to you on Thursday.
Oh, that works. Okay.
Okay. All right.
Thanks.
So right now I need to go to the dean.
Yeah,
office,
you need to go to the dean's office and have the dean sign it.
And the room is 121.
133, which is one aisle on that side.
Okay.
It has a glass door. It's approximately that way.
133.
Yeah, 133.
Are those files you saved on
Mm-hmm.
Moodle? Are those files you saved on Moodle?
I have not uploaded them to Moodle, but you can remind me to upload it.
them? Yeah. When you upload them, where do you upload them to?
I would just upload them to here, and it would just say the date files. So today's will be like it will be labeled as 2012-02-14 files, and that's basically.
And the classes that you put on YouTube, I couldn't find any recent ones. Are there no recent ones?
The only one that I could not upload was the one from last Thursday, but every other class should be up there already.
How?
You go to my channel. So the way you do it is you go to YouTube, and then you type my name or the channel name, which is Some Profs. You click on the Some Profs channel. You click videos, and it will list all the videos that has been uploaded for all the classes that I teach. It's all sorted by reverse order. So the last one for this class was February 7th, which is 1 week from 1 week. This is the last week because I couldn't upload the one on Thursday.
Okay. Thank you.
Maybe I should just might as well try to get another form. What kind is it?
It's called a time conflict petition form.
I believe they gave it to me at the district office. I don't know.
Oh,
so
at
it's
the-
time. Is this the right one? Time conflict.
Yeah. even though it has nothing to do with time conflict.
They gave
it's
me
the
this at the
form.
counseling office or whatever, but
They have-
I went to the dean's office and they said.
Yeah, the dean's office knows better.
Okay, so 133.
Yep. So you have to fill in your part and then I'll sign my part. You just have to say that you have been attending the class, you have been doing the homework assignment, and now there are open spots and you just want to add to the class. That's all you have to write. It's not really urgent, because
Thursday.
once you're in Moodle,
for this class?
the course code that they want is basically the unique number that identifies this course. So yours would be 10960. 10960.
Okay, so it's alright if I bring it back on Thursday. Still have
Yeah, you still want to do it,
like that, or is there-
sometime soon, but
Again,
but
right.
that's fine. Okay. What happened?
Work went down about half a flight of stairs.
Ooh.
Dislocated the wrist. They said I'm lucky I didn't break it.
Ay. Okay. You gotta be okay with the test. I mean, the test is going to be written.
Probably next Wednesday, next week.
Yeah, next Thursday.
I might be. I think.
You'll be
I
okay.
can move my fingers and all. I just can't move the wrist.
Oh, okay.
It's pretty fresh. It just happened yesterday.
Alrighty.
I have
Okay.
a homework question.
So when we're writing it out for for instance, the pre and post homework that you put off for Thursday, when we're writing it down, you want us to write it just like you showed us with that format, right? With
Yep.
like the
Just change the portion that.
and the F with the thing that means the inverse, right? The
F
with the-
prime. Yeah. F quote.
Yeah.
That means the inverse. Well, in this class it means the inverse. I know, in
So
other
basically,
classes.
just if it's addition, you do subtraction.
Yeah.
If it's subtraction, you do addition. That's
Do you need to do anything with this, or is
Yes,
this
I
just for
do,
me?
but you have to fill in your portion first too. Yep. So go ahead and fill in your portion, and then I'll do the rest. And I didn't stop the recorder.